Hello everyone, and welcome to this 30-minute session about the EA440 single beam echo sounder and its application. Thank you for participating. My name is Teresa Mathisen. I am working as a product manager for the Kongsberg single beam echo sounders. And this webinar is about the EA440 single beam echo sounder, and I hope to bring some clarity and insight to what the EA440 can be used for and how the versatility of the system can solve several of your survey tasks. I'll give a presentation lasting for about 20 minutes. At the end, there should be time for a Q&A session. If you have any questions, please use the Q&A function on the menu bar. The webinar will also be recorded and sent to all of you. And I'll encourage you to answer a short survey after this webinar, so thank you for that. The Kongsberg EA440 is a single beam echo sounder for hydrographic applications, meaning for mapping of the sea. The Kongsberg single beam echo sounder have a long and proud history as a world-leading system for depth measurements. The main purpose of the EA440 is still to measure the water depths. It is a professional and reliable system for depth measurements. But in addition, the EA440 can be used for many more tasks, which I'm going to talk you through today. You can measure the water depths by using a low frequency transducer. The signal will penetrate the seabed, and you may see structures in the ground underneath. By using side-looking transducer, the EA440 becomes a brilliant SIDESCAN sonar system. EA440 is for use in shallow to medium water depths, meaning from 1 to 3,000 meters. For deeper waters, down to full ocean depths, the Kongsberg system is the EA640. It is very similar, but allows for lower frequencies and higher power. This is the equipment that you need. You will need one or several transducers. The performance of an echo sounder is bound by physical laws. High frequencies are necessary to obtain high resolutions, while extreme depths are only achievable with lower frequency, less easily scattered signals. Lower frequency also have better penetration, so if information regarding the makeup of the seabed is required, then a low frequency transducer is necessary. For side-scan sonar application, you need side-looking transducers. And you need a wideband transceiver, in short, a WBT. The WBT will handle and process transmitting and receiving signals of up to 4 transducers with frequencies ranging from 10 kHz to 500 kHz. The EA software, which runs on a laptop or a PC with Windows 10, will support 2 WBTs, allowing for up to 8 transducers in a single EA440 setup. You will finally need a position and heading input. The Kongsberg CNAV, as shown, is a high-quality position and heading solution alternative that Kongsberg offers. For portable or small boat operations, or just ease of use, the WBT and the laptop comes in a splashproof suitcase. This also comes with 4 channels and is powered by a 12 to 15 volt power supply. The suitcase with its contents weighs around 11 kilos. The EA440 software is designed to be user-friendly and intuitive. Depending on your requirements, you can set up your views to show the type of data that you are interested in. Data are shown in echograms for each channel. Each channel can be configured separately, such as setting the range with which defines start and stop depths of the echogram. You can adjust gain settings and colors to improve the appearance of the echograms, and you can adjust power output settings. Even though the EA440 software is easy to use, it's very powerful in its many features and functionalities. The list of features, interfaces, and output formats is long. And this versatility allows the EA440 to be configured in a number of different ways for a number of different applications. New in the latest release is the map view. The map view provides a geographical display of the vessel and its track. If the EA440 is used in SIDESCAN mode, it will, in addition, show an approximate SIDESCAN coverage. The map is currently from either of the online map services, OpenStreetMap or Bing Map, meaning that you need internet access. If you don't have the internet access, you can still use the map framework to display the vessel track on Graticule lines, giving you the overview of your coverage. The map will be shown as one of the tiles, or the window can be docked and shown on a separate screen, so you can see both the map as well as monitoring the echograms. This is a new feature available from upcoming release, and it will be gradually developed and to include more features and functionality. I'm now going to focus on the various applications of the EA440. Due to the number of configuration options, as well as using the wideband transceiver that allows for observations in the range from 10 to 500 kHz, there are many applications. I am going to go through some of these and show you the required setup and how you can benefit from these. All applications can be configured with the same EA440 software, the same WBT, only by changing the transducer setup. Let's start with the EA440 as a depth measuring device. This is what the EA440 is world leading in doing, providing accurate and reliable depth measurements. The algorithms used to detect the bottom is world-class and have evolved and developed since the first echo sounder for the commercial fishing fleet came on the market in 1950. Now we are using CW pulses and FM pulses to achieve both high accuracy and resolution, as well as reaching deeper and longer than ever. If you need to measure the depths, either in shallow waters or at higher depths, this is the configuration you need. You need the WBT, which provides you with 4 channels for 4 transducer inputs. You need a computer with the EA440 software, and you need a position and heading input. Then you can select the transducer type and frequency suited for your needs. For depth measurements, the EA440 support transducers from 30 kHz for deeper waters up to 500 kHz for extreme shallow waters, and any combination between from the range of transducers that the EA440 will accept, both Kongsberg transducers as well as third-party transducers. Raw data can be logged and replayed if necessary, or depth measurements can be output to external systems that you may have integrated with other measurements that you are doing. The performance can be enhanced by gain and power settings and monitored via various echograms. This video shows an example how the depth measurements from a 38 kHz transducer to the left and a 200 kHz transducer to the right, collected by this 38-200 combi transducer shown in front. The 200 kHz defines the bottom better at these shallow depths, which is only around 20 meters. Whereas the 38 kHz signal penetrates the seabed and gives an indication of the seabed conditions. The combination may also come in handy when moving to greater depths, since the 38 kHz will reach deeper than the 200 kHz. The ability to deploy up to 8 transducers means that a single EA440 can be configured for simultaneous depth observations at different locations of an installation, e.g. on a boom to measure spot depths across a wide swath. These images illustrate an example where the EA440 is set up to measure depths across a river. The software will log and monitor up to 8 simultaneous depth measurements, each observation configured and presented separately. You will need 2 WBTs and a network switch to operate 8 transducers. EA440 also supports SIDESCAN sonar surveys. By applying SIDESCAN sonar transducers, the system can produce high-resolution sonar images of the seabed over a wide area. The SIDESCAN transducers are mounted to point approximately 15 degrees from the vertical and zonifying the seabed to each side. SIDESCAN sonar surveys are ideal when you want to create images of the seabed and to detect objects that stands out from the surroundings. This can be wrecks, cables and pipes, boulders, or any obstacles that may prevent safe navigation. SIDESCAN sonar surveys are also used to monitor riverbanks, erosion, landslides, and flow-induced sediment deposits. The SIDESCAN sonar setup is the same as for the depth observations. The WBT is the same, and the software is the same. The SIDESCAN transducer uses 2 of the 4 available channels of the WBT. There are still 2 other channels available, e.g. to add a vertical depth transducer. This is recommended for reliable depth control. The Kongsberg SIDESCAN sonar transducers are available with operating frequencies at 200 kHz for best range or 500 kHz for best resolution. The interpretation and understanding of SIDESCAN sonar images is quite intuitive. The images are high resolution, and it's easy to tell directly in real time if there are objects of interest on the seabed. Any findings may be marked in real time by the EA software, such as shown here, where an anchor is identified. The software will store all raw data. You can also output the raw data to a third-party system that you may be using, or you can export via well-known export formats such as XTF. Kongsberg also offers Sonar Mosaic, which is a utility software package for enhancing the SIDESCAN sonar data, making better images. Sonar Mosaic may also stitch several SIDESCAN images together, creating mosaic of your images and making georeference maps with data from all your survey lines. The next application I'm going to talk about is the sub-bottom functionality of the EA440 system. As you may see from the sub-bottom setup shown here, the WBT and the software remains the same as for depth and SIDESCAN applications. The transducer for sub-bottom functionality is one of the larger low-frequency depth transducers. This is a 15 kHz transducer. The EA440 sub-bottom functionality is limited to 300 meter water depths. The optimal water depth for sub-bottom imaging using the EA is, however, shallower waters. The sub-bottom functionality occupies only 1 of 4 available channels, and there are still 3 available channels that can be set up for simultaneous vertical depth and or SIDESCAN observations. Sub-bottom profiling is used to image the sediment layers below the sea bottom to understand the sub-bottom conditions, such as sediment thickness or finding the bedrock. Different bottom conditions, rock, sand, mud, etc., will result in different bottom echoes in the echogram. The interpretation and understanding of a sub-bottom data set is not as intuitive as for SIDESCAN images, and normally it takes a geologist with further background information to tell what a sub-bottom image shows. This beautiful sub-bottom image is acquired using the EA sub-bottom setup. It is acquired by Stockholm University. The sub-bottom image shows a vertical slide underneath the vessel as the vessel moves along a line. For each strong color line in the echogram, the signal has encountered a change in the sediment structure. From this image, you can tell that the bottom contains several thin layers of sediment. Stockholm University has explained to us that this is an indication of layers of biological deposits, such as those from trees and plants. The final output from an EA440 sub-bottom dataset will normally be SegWi files, which is an industry standard. The SegWi files are then used by geologists in other software packages for interpretation and creating maps of the sub-bottom conditions. The EA440's sub-bottom functionality is an inexpensive and portable solution, well suited for imaging the top layers. In this example, we see around 5 meter penetration at around 8 meter water depths. If you need sub-bottom data for deeper waters and higher penetration, Kongsberg also offers a wide range of high-end sub-bottom profiler systems, such as SPP29 and the Topaz systems. As you probably have figured out, now all the above application, vertical depth, SIDESCAN, and sub-bottom functionality can be operated and surveyed in one EA440 configuration. The WBT gives you 4 channels to use, and the choice of transducer is the key. A well-proven setup is: on channel 1, use a 200 kHz depth transducer to give you high accuracy and high resolution depths. On channel 2, use a 15 kHz depth transducer for sub-bottom imaging. On channel 3 and 4, 200 or 500 kHz SIDESCAN transducer, looking port and starboard for imaging the seabed. To make this even easier, a tailor-made bracket to fit this transducer is available. You can here see how the SIDESCAN transducers, the 200 kHz transducer and the 15 kHz transducers may be mounted. The splashproof suitcase is not necessary, but may be handy for smaller vessels. I'm going to show you some more examples of how the software may present the different echograms. First example shows the 15 kHz sub-bottom at the top and the 200 kHz depth below. This is a typical SIDESCAN sonar view with depths to the left and the SIDESCAN sonar images to the right. And this shows how the map would look together with depth and SIDESCAN echograms available from next release. So key takeaways so far. The EA440 can provide you with survey solution for all these types of surveys in one system. Depth measurements, sub-bottom observations, and SIDESCAN sonar for seabed imaging. The final application of the EA440 that I'm going to talk about today is the hydrophone application. By connecting hydrophones to the WBT, the EA440 can be used to monitor and visualize the noise level picked up by the hydrophones. Kongsberg hydrophones are used. These are high-end hydrophones with working frequencies from 1 kHz to 90 kHz. Connected via the WBT, the lowest frequency that can be monitored is 10 kHz. Typical application areas are to monitor vessel noise, such as that from propeller, or to listen to other hydroacoustic systems. The setup for the hydrophone application includes the WBT and the EA440 software. The hydrophones requires external power, so an extra connection unit is required. The results are shown in spectrograms, such as seen on the left side of this slide. The spectrogram to the very left shows how an EM304 multibeam echo sounder will stand out in the 30 kHz frequency area. The image in the middle shows propeller noise only. And the image to the right shows how the picture when both propeller and multibeam system is off. And that, ladies and gentlemen, concludes my presentation. Are there any questions that we have time to look at? We have about 8 minutes remaining. Okay, there is a question here. Sorry, you missed the first bit of the presentation. You say you have an EA400, the previous system installed. Is that still compatible with the EA440 software? i.e., can we still use the transducer fitted? Yes, that you can. The answer to that is yes, you can still use EA440 software. However, the map functionality will not be supported by the GPT, the old hardware solution. And then there is a question, can hydrophone application be used for maritime mammal detection? No, it's not suited for that because as far as I understand, the mammals will have talks on a lower frequency below 1 kHz, and this application is limited by the WBT to start from 10 kHz. So for mammal protection, there are other systems available that would be better. Then there is a question about using this for UXO survey. For UXO, exploded objects on partly buried on the seabed, you could use the sub-bottom functionality of the EA to search for UXO. But depending on depth and penetration, this may be a limitation. Okay, I think that concludes the questions. So thank you again for joining this webinar. As mentioned, the webinar is recorded and a link to access the video will be emailed to you. And I also hope that you'll take the time to respond to the questionnaire that follows. Thank you again and all the best. Goodbye.